Good morning, Tahmina Khan is here in TKMaths is Fun. In this video, which is part 7 on integration, we will see or we will study the use of partial fraction in integration. So let's begin with the question. Partial fraction you have already done in advance before this topic. So partial fraction depends on different type of denominators. Here we have a linear function and a quadratic function. So we know that when we write the decomposed form of this partial fraction, because of this linear function x plus 1, we write a, and because of this quadratic function, we write bx plus c. So after that, we will take LCM here of this side, and it will become x plus 1, x squared plus 3. This a will multiply by x squared plus 3. And this bx plus c will multiply by x plus 1, right? After that, because the denominator here and here is same, so 3 minus x is equals to this numerator. And why it is looking different? Because bx will multiply by this and c will multiply by this. So here it is written in the split form. Now to find out the values of unknown a, b, and c, you can take or you can do two methods here. One is comparing the coefficient method, in which you expand this side and compare it with this side. It will be a little lengthy, whereas if you will do substitution method, it will be shorter. So I'm doing here by substitution method. Because there are three unknowns, so we will substitute three different values of x. So, and you try to take the values which are small and can turn the term 0. So first value I'm taking x equals to minus 1. Because this is an identity, it can take any value of x, right? So if I take x equals to minus 1, minus 1 plus 1 is 0. So this term will disappear. If I take minus 1 here, minus 1 plus 1 is 0, this term will disappear. So two terms will disappear, right? So let's see how. So if I'm substituting x equals to minus 1 throughout in this identity, it will be 3 minus minus 1. All the black colors are replacing x by minus 1. You can see here in this equation. So all the black minus 1 are actually replacing x. After that, it is simple calculation. You can see 4. This is plus 1 plus 3 is 4a. Because this one will be 0, so whole term will be 0. Because 0 multiplied by anything is 0. Then again, this is 0, so I've written here 0. Now 4 equals to 4a and a is 1. So this is how you have gotten the value of a. Now you have to get the value of b and c also. So you need to substitute something else. For example, you can take x0, you can take x3. So choice is yours. You can take any value. So now, for example, we are taking x equals to 0. So you can plug it yourself and you will see you will get 3 equals to 3a plus c. So you can do in detail like I have shown you working here. So substitute 0 and you will end up with this equation. And a is 1. Already we have found in the first equation. Plug in here. So 3 minus 3 cancel out. C is equals to 0. So this term is 0. Then third substitution, we are doing x equals to 1 throughout. So when you substitute 1 here, 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 and here, you will end up at 2 equals to 4a plus 2b plus 2c. So if you want to do it yourself, put the video on pause and try it. Then substitute the value of a and c here. A is 1, c is 0. And you will be able to get the value of b, which is minus 1. So once you get the value of a, b, c, you plug in here. So this is 1, this is minus x because b is minus 1, and this is 0. So you will get this term, right? See here, if I put here 1 over x plus 1, and b is my minus 1, c is my 0. So minus plus is minus. So this term will become minus x because 0 will not be counted then. So that's why we got this decomposed form of partial fraction. So basically we have simplified this into two terms. Now actually we are going to integrate. So now we will integrate this term and this term. Now remember, we have just done in previous videos that when we have this type of case, we have to remember that if you have a fraction and such that the differentiation of denominator is present in numerator, then what is the answer? ln of f of x, whatever is in the denominator. So if you differentiate x plus 1, your answer is 1, which is present here. So this term will become ln x plus 1 here, right? But if you see here, if you differentiate 2x, x square, what do you get? 2x. Do you have 2x here? You don't. You have only x. So you need a 2 here. So see here how we will do it. I'm only explaining you this term now, right? So because I want 2 here, I can do 2 divided by 2 into x square plus 3, right? Then I can bring this 2 here. Then what it will become? It will become 2x minus 1 over 2 will remain here, x square plus 3. So now the denominator is x square plus 3. If you differentiate it, it is 2x, which is present here. So now it is easily minus half ln of this term because we are applying this formula, and plus c because there is no limit. So this will give you the answer. I hope you understood this. Now, one more question I will do. That was of indefinite integral because there was no limit. You can see there is no limit. So one question I'm solving with limits, definite integral. So if you look at this, this reminds me of partial fraction. Why? Because x square minus 2 can be written as x square minus root 2 square. So this is by x square minus a square form. And what is x square minus a square? Do you remember algebraic identity? It is x minus a, x plus a. So I will change this denominator into this form because x square minus root 2 square. So this is a square minus b square. So a plus b, a minus b. So we are applying this algebraic identity here. After that, because this is all talking about integration, so first of all, we have to simplify this function. Only then we will be able to integrate it. So after changing this into this form, now I can decompose it by partial fraction because now the denominators are two linear functions. So it will become a over this plus b over this, right? Because from the partial fraction, we know what type of constant we take in the numerator. That depends on the denominator. It's a linear function, so a and b will come here. Now after that, I will take LCM on the right hand side. When I will take LCM, a will multiply by this, b will multiply by this, and on both sides we have the same denominator. So we don't write it. It cancels out. Now we have to do substitution. So for me, I will substitute x equals to root 2 because root 2 and minus root 2 will cancel out and I will be able to disappear one term. Easy to calculate. And second time I can substitute minus root 2 because minus root 2 plus root 2, this will cancel out. So always take a number which can help you to eliminate a term. Otherwise, I can take x1, I can take x0, but then I have to calculate, do little more calculation, simple. So let's take x equals to root 2 and I will plug in here, here and here. So in the black color you can see I have substitute. When there is no coefficient, it means it is 1. 1 plus 3 is 4. And why this is 0? Because root 2 minus root 2 will cancel out and it will become 0. So that's why I've written it 0 here. Now this thing is actually 2 root 2. Why? The coefficient here is 1. Coefficient here is 1. So it is 2 root 2. Now this will go here as a cross multiply, we say. We know the reason behind it, why. And I got the value of 2 because this will cancel out. 2 1s are 2, 2 2s are 4. You got the value of 2. B. Now you have to get the value of a. So now I will substitute x equals to minus root 2, right? So when I substituted minus root 2 in this equation here, here, and here, so this term will become 0. Reason? Because minus root 2 plus root 2 will cancel out, and this will be 0 multiplied by b is 0. But this is minus 1 plus 3, so it will become 2 root 2. And this is minus 1, no coefficient mean 1. Minus 1 will be minus 2. And then simply cross multiply, and you will get the value of a. Now a is minus 1 and b is 2. So I will plug in here the values. Okay. So after plugging in the values here, now I will integrate it, because this was my main function to integrate this. So instead of writing it now, I will write this. And that's why I have done the whole process of decomposing it. And then I will apply limit 2 root 2 to 3 root 2. So when you integrate it, it will be integrated both the terms. Okay. So if you want to split, you can. If you don't want to, you do not need to. But I'm just doing it to show it to you. So I'm applying integration here. Why I have taken minus 1 outside? Because I want to apply this strategy, this logic, this formula. If you differentiate denominator, you will have 1. So I just want 1 here. Similarly, this 2 as a multiplier going outside. So now if I differentiate denominator, I have 1, which is here. If I differentiate this side, I have 1, which is here. So straight away, this will be ln x plus root 2. This one will be ln x minus root 2. So you can see here in green and in black, I have shown here. This plus 2 outside and this minus 1 is there as it is. After that, we will simply doing upper limit minus lower limit. So in place of x, I will plug in this. This will go here. So, and then I'm substituting same thing here, upper limit minus lower limit. So you can see here the calculation. I've substituted here upper limit, then minus lower limit. Now be very careful. This minus I'm keeping at the moment at the back. I mean outside the curly bracket, because I'm doing upper limit minus lower limit. So this minus is coming because of that. Similarly, plus 2 is outside. Upper limit here minus lower limit. Okay. After that, simplification. 3 plus 1 is 4. 4 root 2. 2 plus 1 is 3. 3 root 2. I'm not removing the brackets yet, right? 3 minus 1 is 2. 2 root 2. 2 minus 1 is 1. And this minus is because of it. So it is 1 root 2. After that, if you remember the algebraic rule, I will apply that. That is algebraic quotient rule or product rule. Before that, I am opening the bracket. Minus is coming here, plus is coming here. And here 2 is multiplying by each one of them. There are 3 ways to do afterwards. So I'm writing this first, writing this second. I'm applying power law. So this 2 will go up here, right? So that's why it will become a square. Same thing I will do here. This 2 will go here. It will become a square. Looks dirty, but actually it is 2. Okay. After that, I'm applying ln a minus ln b. So it is ln a over b. And here it will become 2 square is 4. And this is only 2. And this is only 2. Right? 4 2s are 8. And here this 2 cancel with this 2. So I have 3 upon 4. Now we know when we have plus sign, the terms are multiplied. When there is minus sign, the terms divide. Right? So that's why this will go in division and this will go in multiplication. So 2 1s are 2, 2 4s are 8, 4 1s are 4, 4 1s are 4. So you got ln3, which you have proved. This is what you had to prove. So this is how you will handle these type of question. And I'm giving you here 4 practice questions. And here are the answers of those questions. I'll show you at the end. Be very careful. This is again linear. So it is a over x plus b over this. linear denominator. So a over this, b over this. Linear and algebra, a over this plus bx plus c over this. Here it is repeated root, so it will be a over x plus 1 plus b over x minus 2 plus c over x minus 2 square. So this is how you will deal it, right? So try to do these questions. Here are the answers. Hide them. Do not see them before doing it. So then in the next video, it will be integration by parts. And then the last video will be on the past paper. Thank you very much for watching. Take care.